get it. All right, so I am on page 199. Fill in appropriately. If your answers are different than mine, let me know because I probably made the mistake. All right. So 3.7 talked about when you add something or multiply something to a mean and a standard deviation, what changes? So do what? Here, I'm gonna do what I do in my. I'm gonna do what I do in my other classes. Can I sit behind you? Okay, I just want to make sure. This is what I do in my freshman class because they don't know how to behave. No, you guys are fine. No, I just wanted to be comfy. It gets lonely up there all by myself. I need to sit amongst greatness.
You don't want to look at us?
Nah.
Wait, what page do you want to
Page 199. Got it up on the board. All right. It says, assume the data set was given with a mean of 50 and a standard deviation of 9. Okay, so this was some study, something had happened. So what happens when we add 15? Okay, well, the average changes, but the mean stays the same because addition and subtraction are low orders of operation. They don't change our data. Problem number 2, if we triple it, so your times and everything by 3, you triple it, your mean becomes 150 and your standard deviation becomes 27. Multiplication is a higher order, so it changes the outcomes of things. And then number 3 says we double each number and then subtract 30. So that means that our mean 20, thank you. This is why I need to sit amongst y'all. You know how to read better than me.
Don't worry, sir. I'll correct you.
Yeah, she will.
Feels like my wife.
Yeah.
All right.
I don't know if that's a good thing or a bad thing.
My wife's smarter than me. All right, so we're going to double and then subtract 20. So I'll double the 50 to get 100 and then subtract 20 to get 80. And then the standard deviation will be doubled, but we do not subtract. Okay, so multiplication and division will change both the mean and the standard deviation. If you add or subtract, it does not change the standard deviation. It just changes the mean or the average. Okay, pretty easy. Let's see. Next, talks about a psychology class. Gave a quiz that was worth 20 points. Assume that the scores are normally distributed. The class average is 16 with standard deviation of 3. The teacher may choose about how to curve the results for each answer. Okay. So this is problem number 4. So they said average is 16, standard deviation is 3. All right. So for the letter A, if they double every score, then your mean is going to become 32. And your standard deviation is going to become 6 because doubling is multiplying by 2. B, if we add 50 to each score, that will change my mean to 66. Keep the standard deviation the same, original same, not letter A same. And then letter C, multiplying every score by 5, then subtracting 15. Multiplying every score by 15. So it's going to be 16 times 5, which is 80. And then we're going to subtract 10. Okay, so my mean here is going to be 70. My standard deviation, I would just multiply my standard deviation by 5. I do not subtract. Okay, so this does not change the normal distribution. It just moves. Basically, the mean is the only thing that's moving. Unless we're multiplying, then the standard deviation gets spread. Number 5 says the teacher multiplies every score by 5. What percent of the students will get a 90% or higher? Ooh, okay. So assume that the teacher multiplies every score by 5. What percent of the students will get 90% or higher? So let's think about this. So it's going to, this is number 5. So we're multiplying by 5. So if I multiply by 5, that means we're using this situation. So 70, this goes to 85, and then this goes to 100. And yes, I could fill out the rest of it. But what we want to do is what percent will get a 90 or higher? So a 90 score is about here. So we're worried about this. Okay? So this is one of our calculator commands. We're finding an area. If we find an area, it's what? Normal CDF, thank you. So I'm going to go second. Distribute. Normal CDF, number 2. So I want to do this way. I want to go 90 and go an upper score. Make your upper score much bigger than 90, so we can go 1,000. Okay, some people will go beyond that. And then, I forgot what the mean was. 70 and 15. So 70 and 15. Paste, enter one more time. So it looks like about 9.1% of our students will get a 90 or higher if we had multiplied our original score, our average score, by 5. So that seems about good enough. If the teacher adds 80 to every score, what percent of the students will get a 90 or higher? So this one I'm going to make, so the first one is going to be about, what did I say, 9%? Is that what it was? 9.1? Okay. And some of you struggle with that when I was helping you a little bit yesterday. If you have a decimal and you want to make it a percent, move the decimal 2 places left. So 0.091 and 9.1% numerically are the same thing. But 0.091 and 0.091% are 2 different numbers. Okay? So then I was looking at number 6, and they said the teacher's going to add 80 to every score. So this is going to change my mean. If I add 80, I get to a 96. My standard deviation is still going to stay at 3. So think about what this is doing. If we draw our normal curve, this is going to be 96. Standard deviation is 3. Okay, so we want to know at this point how many will get a 90 or higher. Well, 90 is like over here. Okay, so do you think that this is a much larger area than 9.1%? This might be the way you might want me to grade. All right, so I'm going to go normal distribution, normal CDF. So we're going to do 90 to 1,000, and we're changing the standard deviation or the mean to 96 and 3. This is what I should do for you guys' final. Because that means that 97.7% of you would get the 90% or higher. Then you have the one kid going, I didn't get the A. Yeah, so you must be part of the 2.3% crowd. So that's one heck of a curve there. That you find out which college teacher does that and take that class. All right. After that, it says I'm on page 200 now. It says, Mr. Jenkins, drive to work. Wow, this is good grammar. Mr. Jenkins' drive to work takes, on average, 38 minutes with a standard deviation of 8 minutes. Okay. Assume his drive times are normal distribution. If Mr. Jenkins is pulled over by a police officer for 15 minutes exactly, what is the new mean? Well, we're going to add 15 to the 38, so we're going to get to, what is that, 53? And then the standard deviation will still stay 8. Construction doubling is commute time. So what is the new mean and standard deviation? So if it doubles, so that means he goes 76 minutes on his drive. And then we also, because doubling is multiplication, his standard deviation goes to 16. And then number 9 says Mr. Jenkins works at 8 a.m. sharp. He leaves at 7:20. What percent chance will he make it to work on time? Okay, so let's think about this. So this is just going back to the normal situation. So we have, I'm going to go back to normal CDF. Okay, so if he leaves at 7:20, he needs to be at work at 8. So Mr. Jenkins leaves at 8 a.m. sharp. If he leaves at 7:20, what is the percent chance that he will make it to work on time? Okay, so I'm going to have my lower limit 0 because like he drove really fast. I'm just kidding. 40 minutes here. And then they say that the mean is 38 and our standard deviation is 8. So if we do this, this kind of works as a probability because probabilities are percent. So the probability he is on time is 59.9% of the time. Ooh, we could do a problem about, what's the probability Geo is late every day? 100%. With standard deviation 0. Just kidding. I'm just funning you. You got here early one time because.
Yeah. One time.
What you drinking? That looks kind of fun.
This is Dutch Mojito Rebel.
A Dutch Mojito Rebel.
He's
drinking in your class.
All right.
No. It's coconut, lime, and mint syrup
Yeah, baby.
with energy drink.
I'm in. I like it.
It smells like a Jolly Rancher.
It's amazing.
Oh, I like it. I like it.
Come through on Saturday or Sunday, and I can get you one.
Okay, I can buy them too. It's not a big deal. I got plenty of money. I knew I learned how to live within my means about 35 years ago, and life's been pretty damn good.
That's smart.
Yeah.
Wait, Jay, which one do you work at?
The one
On the Arapahoe? What times do you work?
Because
Because, like, I work right by where you work on Saturday and Sunday.
Saturday I'm 11:30 to 6.
Shut up. Because I work 9 to 2. I'll work
No way.
We'll see each other.
Or we can
You know what? I don't work Saturday.
Yeah.
Wow.
That's a good life right there.
Yeah, you
Work
know.
all weekend.
Plus, you're a full-time student, so you know that. All right. If Mr. Jenkins gets pulled over by a police officer on his way to work and leaves at 7:20, what percent chance will he make it on time? Okay, so I think we can do this again with normal CDF. 2. All right. So if he gets pulled over by a police officer, we set it up above. The police officer added an extra 15 minutes to his commute. So that's going to be 53. Our standard deviation, oops, hang on, I got to change this. This is 53. Standard deviation is still going to stay 8. If I do 0 and then 53, okay, because he's still trying to make it on time. Okay, so this is going to find us the area that is below that. Okay, so normal CDF. Oh, wait, I think I goofed up. Hey!
I just want to see how long it would take us to. Do we get to use calculators, they want to know, on every capstone test?
Yes, so every problem has Desmos built in on the computer. They can also use their own calculator or a borrowed calculator. So they can, and scratch paper. And then they can use their phones, take pictures of it, and sell it, and then we get 10% of the profits.
Okay.
All right.
That's why you have so much money, huh, Sarah?
That's what my
You
name
sell tests, huh?
I'll just say that American funds, mutual funds, large cap industry, which is a mutual fund that it's changed lots of different companies over the years. But since 1989, it has been about 17 times growth.
for selling tests.
No. It's a financial investment.
That's like, I'm like, wait, people actually do that?
Yeah, my bank account's a little low right now.
So
As soon as my paychecks start coming in,
I'll just say thank you to COVID because large cap American funds has companies like Merck, Johnson and Johnson, Pfizer. Since COVID started, it's up 176% of what I had invested. Like, I kid you not. It's like, so I get these statements going, ooh, the decimal place moved over one. So it went from $10 to $100.
Yeah.
All right. I'm trying to figure out this problem, and I've goofed it up. All right, so lower 53, the mean. Oh, wait. The upper is lower upper, so that means he still has 40 minutes. All right. Yes. No. Yeah. Yes. I have it right now. I think I have it right. I got confused on some investment stuff. All right. So there we go. So we have. They're saying that from zero because he's not gonna have negative time. If getting pulled over takes him 53 minutes, but you still have that standard deviation of 8, what % chance is that he's not late in his 40-minute drive that's now taking him 53 minutes with standard deviation 8? So he has a 2.6% chance of not being late. So there is a chance. Geo, there's a chance. There is a chance.
There's a will. Or wait. No, if there's a will, there's a way.
So Geo, I imagine this is kind of conversations that you're thinking about at home. Okay, it takes me 15 minutes to get to school with a standard deviation of 7. Okay, I'm guaranteed he's doing this. So what happens if we leave 12 minutes before the bell rings? What's the chance I get to school on time? It's gonna. So I mean, because look, like this poor fellow's only got a 2.6% chance of making it on time. It happens.
No, but I can make that like.
You can make it work.
So you watch. I bring him up in this story. He's gonna say it on Monday.
Put him in the
Stirrup.
Yeah.
Stirrup. Well, if I put what's the probability that Gio's gonna be on time, y'all are gonna get it right, saying 0% chance. Because you can easily just threaten him and say, well, Gio, I would need 100% on this test, so you better not show up on time ever. And so we can influence the outcomes.
Yeah, but then how do I get some of those points?
I don't know. All right. I forget what number I'm on. Oh, we did the police officer one. Yes. If construction commute, what % time? Okay, so I'm going to go second, distribute, normal CDF. You guys seeing a pattern here? So the construction time, it doubled our situation. So then we're going to change we still needed to go 40 minutes. And then he's going to go, it doubled. So we're going to go 76 here. Because we doubled, we have to change our standard deviation to 16. And then we do that, boom, boom. So Geo, even though it doubled your commute, there's still a chance you'll be on time. Got a 1.2% chance. So you're saying, what's the chance I pass this class? You got a 1.2% chance. So you're saying there's a chance. I'm kidding. You all are going to pass. I'm sure. I hope so. Okay. If both events are occurring, oh my goodness. If both events are occurring, construction is doubling, and he got pulled over by Johnny Law. Woo-hoo-hoo. The verbiage you get out of Stirrups class is just helpful. All right. So he still has 40 minutes to get. So, what'd I do? Scott, you gotta remind me to unmark you from being absent. Don't leave until I do, okay? All right. So I need to add 15 to our 76. 15 plus 76 91. Standard deviation still stays at 16. So Geo, even on the snowy worst day, even though...
Not even bring up this.
Oh!
I've never driven in the snow before.
So stay off the sidewalks,
Basically.
because here comes Geo.
And don't expect me to be on time. I will be going the slowest I have ever gone.
All right. Hey, friends, 7.176, and then it has this e to the negative 4. So that basically means 0.123717. So that's what that e to the minus 4 means. So if I multiply this by 100, oh my goodness, he has a 0.07% chance of making it on time if he got stuck in construction, and he got a ticket as well because the police officer stopped him. There's still a chance. Yeah, there's probably a better chance of getting struck by lightning and living though, but
What's the chance of me being 1 in a million? You're saying there's a chance.
there is a chance. There really is. All right, so how do we feel? Is this okay? So we utilize normal CDF like on steroids. All right, so I'm going to talk about, I'm not going to, can I have a funner day? Funner day? Is that okay?
Wow.
Can I say funner?
Yeah.
We're not in grammar.
I mean, I don't think it is, but technically I think. But it's in the dictionary, so I just remember this like a couple of years ago.
Yeah, but it's literally the dumbest word.
All right. All right. All right. So, Gio, can you be an example in this fun time?
One time.
Thank you.
Every day.
All right. And who else can I pick
You
on?
spelled my name wrong.
Well, that way I protect the innocent.
Yeah.
Guys, we're not talking about RGO, it's somebody else.
All right. There you go.
Yo, compare Scott and Gio's charts together.
Talk about how many.
I don't need to get a phone call from Scott. Can I use you? All right.
Scott, it's like, what's the probability he will come to class today?
All right. All right. All right. All right.
There's a
All right.
test. 0%.
Okay. So Gio's chance of making it to school on time. He makes it up to school on time, on average, 15.15, with a standard deviation of 0.03. Okay, there's a 15% chance that Gio's going to make it on time to school. We still there? Scott, it's no mystery. You have missed quite a bit of school. So Scott has a 0.07% chance of making it to school with a standard deviation of 0.01. Okay?
One whole number.
Wow.
Just having fun. Oh, I'm sorry. Good. All right. So my friends, do we agree that we're comparing two students?
I can agree with that.
And both students have a different mean as far as a percent chance of making it to school on time? And they both have a different standard deviation. All right, so we'll play around with this more on Monday because I know I'm running out of time. So what I'm going to do is if I want to combine the information, I add the means together. So I'm going to go 0.15 plus 0.07, which gives me 0.22.
You gotta bring Gio's average down.
Yeah. But Scott's coming up. And then what I want to do with the standard deviation is basically this. It's the square root of 0.03 squared plus 0.01 squared. Okay. So I need to know someone with a calculator. Oh, I got one. So second square root, what did I say, 0.03 squared plus, what was the other one, 0.01? I don't know, I'm not paying attention. Stir up, there's something on my phone. All right. So our standard deviation is now going to change to 0.03, and we'll just keep it at 0.03. All right, so then our standard deviation changes to 0.03. All right, you ready for this?
3% chance he and I will be in school on time.
All right, well, thanks for bringing that up. Okay, hey, somebody do me a favor. Will you write down 22 and 3 for me? Because I'm going to my calculator. All right, friends. You want to know when we buy a lottery ticket? Is when this event happens. Okay. So what was the mean that I said?
Well, I have the two numbers. There's the first number and the second number.
First one.
22.
Thank you. 22. Second number is
3.
3. Oh my goodness. So the chance they make it on time.
Both of them on the same day
Uh-huh.
at 8:20.
At 8:20. So they both have a 15-minute commute. They have 15 minutes to get to school.
It just told me that I'm hardcore.
Yeah.
Okay, I think I'm doing this right. Hang on, I might be wrong though. I might be wrong.
I'm flying to
Oh!
See, wow. Yes.
Being they both have a 15-minute commute to get to school, we have less than a 1% chance that they will both make it to school. There is still a chance. But, friends, if this happens, we do a field trip over to the C-store. You still with me on this? And we go buy all the lottery tickets because we're going to win. We'll split the winnings, though. And don't worry. If you're not old enough to buy a lottery ticket, give me the money, then I'll go buy it. And also we're outside all scratching, and all of a sudden Gio's like, dude, I won! And we're like, yes! How much you win? $2. Oh, we got to split it up.
That's hilarious.
Yeah. So my friends, we are going. I have not taught the lesson on this. I just wanted to give us kind of an introduction. We will see this on Monday. Is anyone going to be overly upset if there's not a homework assignment over the weekend?
Oh yeah, for sure.
Am I getting emails from parents again?
Yeah, Callum really was.
Again?
Yeah.
I go straight to my mom every time you don't assign me homework.
It's like, Mom, it's not fair. It's not fair. Humanity.
Well, Sire gets homework all the time. And my mom, when I say, yeah, I don't really have any homework, my mom's like, really?